I am standing outside of a zone system install I did back in 2011. You guys can remember, some of you who watched it back then. It is tight stuff. There is our ICM CC750-230. That is our variable frequency drive, variable voltage drive for this fan motor. Up on the top is our zone board. Right now the fan is in circulation mode, and what I did, I programmed it to run at 30 Hertz in circulation mode, which you might be able to see on there. See that it says G-call 30 Hertz, and you can hear it running. It's running at a very low RPM, just like you would for a variable speed motor if it was, you know, set on fan only, except that this is a PSC motor that's controlled by this drive. So we're going to get into how this drive works. I'm going to set up the I manifold outside. Well, we were talking about, we were running on 30 Hertz, and it ramped up while I was talking to Ralph and lubricated the bearings of the blower motor, because it has to have enough RPM to keep the bearings lubricated. If it runs on low speed for too long, the motor likes to ramp up and make sure the bearings will be okay. You don't have premature bearing failure. So we're running at 30 Hertz right now. We're going to set things up in the I manifold outside. We have our I manifold gear and my static pressure probes. We're going to put those in too, although I'm sure the static will be super on my crammed in there duct system. But we're going to check it out anyway and see how it affects the static whenever the motor ramps up and down. Before I get into the I manifold setup, I am going to take this apart and show you guys how I wired it up, so you'll know. Open up the device itself here on the access point down here at the bottom. Open up the air handler and see how I wired it. But first I have to shut the breaker off over here, and we can get to work. As you can see inside of the device itself, there are 4 connections you have to wire up. If you look from left to right, you'll have a neutral or L2, and that depends on what voltage motor you have. This device is built for 230, but there is one built for 115 as well. You can see there's a common, a high, and you can see your L1 on the other side. So you have your L2 or neutral, common, high, and L1. Now the inner 2 are going to the motor, and the outer 2 is power coming from the air handler. All my wires happen to be black, unfortunately. So I'm going to show you a wiring diagram of what's going on here while we're watching the video, hopefully up in the top corner there. So to summarize, guys, we have one wire going back to the motor on high speed. We have one right here spliced in. This is one leg of the power coming into the device. The other leg of the power comes from the actual blower relay, which is really hard to see right here, but you can see it's the wire coming in right there, and the little black blower relay. That's the other leg of power. And then we have right here is our common for the motor. So not too bad. I used all black wires because that's what I had. It's a little bit confusing for the explanation process, but I had all black wires, so that's what I did. I carry a big roll of number 14 stranded wire for this sort of thing. But I put it into a piece of electrical conduit. It goes up and down and into the bottom right there. There is a bank of low voltage connections and 2 sensor connections. Those are the 2 on the left. The sensor connections were already in place when I purchased the device. I just needed to wire up the low voltage, so we'll get a closer look here. You can see R, C, Y2/H, and we don't have that capability with this machine. O, W2, Y1, G, CT, and RT. Now the RT is the return sensor, and we'll show you where that's at here with a little picture up there on the top right corner. I put it on the right hand side of the machine underneath the slant coil. The coil temperature sensor is actually embedded in the coil, and I'll give you a picture of that as well. G is the fan 24 volt wire from the zone panel. Y1 is also the 24 volt compressor contactor circuit from the zone panel. W2 is our heat strip signal from the zone panel. Our O is our reversing valve energized and cooling from the zone panel. We have our C is common, and our R is a 24 volt hot from the zone panel. Now these all come from the zone panel because of that's my thermostat brain for this job. Sometimes these will run back to the air handler in a different application, but for this, it was real easy to go up to the zone panel. This is our zone control board right above the panel. It's offline. As you can see, I just spliced into those existing terminals. You can make a little bit different splice if you want to. Wire nuts, crimped wire nuts, whatever you want to do. You're really sending a signal, a duplicate signal, to this device down here. You're not sending a signal through this device to the air handler. You're just sending a duplicate signal down here so it knows what's going on, so it can control the blower. So that's how the machine is wired up to the device. We're going to check some static pressure. We're going to monitor static pressure. We're going to set up the I manifold. I won't go through all that. And we're going to see how it affects the I manifold pressure, because our pressures will dip and rise. And for periods of time, it'll be below freezing, I'm sure. But the coil sensor will sense a cold coil, and it will shut the machine down if it gets too cold. So you have some protection against freezing evaporator coil. So we're going to set all that stuff up. We'll get it started, and then we'll come back to you. I have my Samsung Galaxy S5 with the information on it from the iManifold. I can't use my tablet here because my tablet's kind of buggy. Whenever it loses a 4G signal, it dumps the iManifold app and shuts it down, so it's just kind of crazy. But it is tablet related, because I've confirmed that this phone works and other devices work. I see up here we have a new insignia. I'll hit that. And that must be the stability indicator that everybody was talking about. So obviously the system's not running in a stable position yet because it hasn't even been started. So we're going to come over here and I'm going to profile a new system. R22, heat pump, cooling. We have a standard TXV inside of the air handler. And we are going with 10 to 12 SEER. And we have a standard evaporator. And we'll just leave those settings right there. Nominal tonnage. You know what, we're going to go with, it's going to be all, that's actually going to not really matter that much, because we're going to tamper with the temperature split so much our airflow reading will be pretty much useless. Okay. So our big check mark up there, let's see what that says. Temperature split and liquid line temp. Check. No, that can't be right. Well, we have 77 and 76, so we haven't started the system yet. We're going to start this thing up with the top floor zone calling, which is they're pretty equal as far as zones. So we're going to see what happens when we turn it on. We'll monitor the iManifold while we monitor the VFD as it ramps up and down, and we'll hook up our static pressure and we'll monitor that as well. We start up with a waiting period, which is almost over. We'll start up the fan motor. You can hear it ramp up. There are a couple loud frequencies. This is 33 hertz right there. 34 hertz, and it'll quiet back down. 35 hertz. See our static starting to increase. You can see we're at 37 hertz. As the hertz increase, we will also increase speed. You see it quiets down a little bit. You can actually take out those noisy frequencies. I just left them in there because with the door closed you don't really notice that much, but you can remove them. We're ramping up to full speed because we definitely need to keep the bearings lubricated, so it's going to ramp up to full speed. As you see, our static is increasing, but not too bad. We don't have hardly any return static at all, because one of our return grills is on the side of the air handler down there, and the other one's goes down through the floor and straight through the wall. So not a lot of return static, but it all balances out. Right now we're looking at a 30.32 total static on this machine, and we're running at 50 hertz. So, and we'll start to ramp downward because our running speed for our G call, which we set up during the setup process, you can see it's loud during 33, 34 hertz. Our running speed is 30 hertz. It just stays at that constantly to mix the air, just like a variable speed motor would. And we have a static of 0.13, very low static, very low amp draw. So we're going to turn on zone 1 and see what happens after we do that. We're set on 78. We're going to go down to 70, so we'll run a little bit. See if we receive our call here in a second. So our coil temperature is 78, our return temperature is 79. Machine's been pretty much offline, so that's why our temperatures are matched up. Let me check my thermostat. Our machine just came on for cooling. You can hear the refrigerant in the piping, you see the pressure start to change. The fan will remain on low speed till the coil gets to the proper temperature. We set up the desired coil temperature, or the temperature split between the return air and the coil, should I say. Right now it's set at 26 degrees, a large split for dehumidification. So we'll see. We're going to see how the refrigerant pressure adapts to that after it builds up over a period of time. Still running at 30 hertz. As you can see, the coil temperature is getting lower. If the coil temperature continues to get lower and lower, you will see the blower start to ramp up to warm the coil to get to the proper temperature split between the coil and the return air. Let's see if we can get down there a little bit farther. See the coil starting to get even colder. See the suction pressure is low because that coil is cold. It'll start to rebound though, because remember, it just started running too. So right now we have a 29 degree split. We should see the blower start to ramp up, and I'll catch up with you guys when it starts to ramp up. You can see that our temperature split is extreme, 18.9 degrees. We'll get up into the 20s easily. That's why we can't use the airflow estimation. And here we are, we see we're starting to ramp up because our coil is too cold. We're into the 40s on the coil. We're starting to get a little bit faster as far as the blower because we want to bring that coil temperature up. As you see, it's 49 right there, 48 now. So we're going to start speeding the blower up. 47 on the coil. Keep following on right there. Our static pressure is at 0.24 total static pressure. We're starting to get a little bit faster. Suction pressure, you know, up in the 60s now. So the motor is definitely speeding up in order to get that coil to warm up a little bit. You see the coil starts to warm up again once the motor ramps up. Now there'll be some adjustment where it'll ramp up and down in order to achieve the right coil temperature. And the idea behind this is that you want to dehumidify the air. 19.8 degree split. You see we have a very high split, and our airflow indicator is, you know, down in the tank because obviously it thinks we have no airflow. There's a reason why we have a high split. Guys, the reason why we're here in the first place is because it's right on the water. There's a lot of humidity. That's the whole reasoning behind this device. You get the benefit of a variable speed, which I think this is actually better than variable speed because you can program it to whatever parameters you want. And you can tinker with it. If it doesn't quite, you run it for a little while and you're not happy with it, you can, you know, shift the parameters. That's why I like this. And then you put that together with a machine like the iManifold, which you can monitor and adjust the entire system. It's very nice. So we're going to continue to watch this. We'll watch the static pressure and see what happens as we turn on the second system. As you guys can see, the blower has started to slow down a little bit to bring the coil temperature back down. We're in the 50s on the coil now. Our static pressure has gone down into the well, it's kind of fluctuating around now a little bit, it looks like. But looks like we're going to enter the 0.2. Well, we're at 0.3, going to go down to the 0.29. And here's our refrigerant pressure, as you can see, below target because we're a little bit lower in temperature. than what we would have if we had the proper airflow. So our Honeywell programmable thermostat, we're going to turn the temperature down on it to 70 as well. This is the humid area. We're going to hold that right now. It's on hold. I do think it needs to be set down relatively low to keep this place from being so damp. We have our grills out there. We have our Daikin up there on the wall, you can see. But we're going to head back upstairs to see how this affects the performance of the machine. We're running again at a very low RPM, 31 Hertz. I'm sure we'll go down to 30. Coil temperature is 52. Return temperatures dropped to 78. So it's starting to cool already. As you can see, our temperature split is extremely high. Our refrigerant pressure is above freezing, but not by a whole lot on the suction side. Static pressure, 0.13, very low static. So big temperature split. You're definitely going to be cold on the coil, and again, you can set the parameters for whatever you want. So I wanted a cold coil for this particular place because I wanted maximum dehumidification without going into freeze mode. We're also going to keep a special watch on the return air relative humidity, which is 74.4%. As you see, we're down in the mid 50s now. We're going to be coming back up because the blower is starting to ramp back up to warm the coil a little bit. We're going to see how that relative humidity goes down. Now, one of the issues with this system is their set points were a little bit too high. They're back up in the upper 70s and the machine is actually not running. So in order to dehumidify, the machine's got to run. Even with extended run cycles and a colder coil, it doesn't help any if the machine's not on. So the set points need to be lowered. Even if the upstairs and the downstairs is the one with the humidity problem, if the upstairs runs, it'll still draw air through the return and dehumidify that air. So it will help, even if they don't want to lower the set point downstairs too much. So as you hear, the blower is ramping up to 36 Hertz. See that now? We're going back up into the upper 50s. It'll start coming up again. What we're going to look at now, guys, are the different settings. You see we're cooling, 32 Hertz, coil's 51, return temperature is 77, so it's coming down. Relative humidity's come down just a tad, right about 74%. We'll put select. Heat pump system, yes, it says O active. That's what we are, the carrier. If you hear, that's our condensate pump. Motor system is single speed, that's what we're using, one speed. Maximum coil temp from that coil sensor inside is 135. Minimum coil temp is 34 degrees, so if it starts to freeze up, it will shut the system down. And you can change those items. Discharge temperature, 100 degrees. So it's monitoring the temperature. That's what they're trying to keep as far as the heating cycle. They want a uniform discharge temperature. So when the machine starts on heat pumps and it's not that warm yet because they kind of have to run for a little while, the machine will vary the airflow to make the air comfortable so it won't be cold. And that's pretty much all of it we have there, guys. Not too bad. Differential was 26 between the return air and the coil. Sorry, I think I missed some. The minimum frequency is 30 Hertz, and that's the minimum. You can go up from there. Maximum frequency is 50 Hertz, and that's the maximum. The G-call frequency, I have it at the minimum, is 30 Hertz, just so it'll mix the air. Humidity sensor, there's no humidity sensor on that Y2, or the H input we looked at on top. I don't have that, so if I learn more about that, I'll let you guys know. The ramp up time is 50 seconds, so it'll ramp up, lubricate the bearings, and go back to whatever speed it was designed for. Post-purge time is 90 seconds, just how long it'll run after the cycle's over. Max cool minutes is 70. It'll run 70 minutes powered off the VFD, and then it will revert to bypass mode, which will run at full speed to satisfy the cooling call. So it'll ramp up so it has more. It'll shift from, because right now we're shifting it over to a more latent cooling to take the humidity out, but after a certain amount of time it ramps up to maximum speed so it can get more sensible cooling so it can satisfy the call. And that's pretty much it. Well, you know, let me make sure, because I might have been talking too long. It has happened. Ramp up time, post purge 90 seconds. I know there's one more at least. Recycle time's 85 minutes, so after that, that's the amount of time it'll spend on maximum speed. You can hear it sort of power adjustment. You know, this machine varies the amount of frequency, hertz, and varies the amount of voltage, and it will actually make the motor more powerful by manipulating those two aspects of the inputs to the motor, and you can adjust that here by going up or down. I think that's it. Yeah, that's it. So we're going to keep rocking and rolling. As you see, we are down to 72.1 relative humidity, and you can see how high the relative humidity is in here, 70%. But I mean, the machine wasn't running all night, I'm sure, so it's dank down there. It has been about 15 or 20 minutes later, we're down into 68% relative humidity. You can see how quickly it declines if the system actually runs. We're turning our dry bulbs down to 72. I want to say we were near 74 before. So doing a good job of bringing the humidity out of the air. So guys, basically I wanted to run through things and show you how it worked, how I wired it up, what application I used it in. I mean, you could use this in any application where you have a PSC motor. I really like this thing. I really like the fact that I can buy this thing and I can buy a PSC motor, I can buy a capacitor, I can buy all that way less than I can buy a variable speed motor. And to me, this thing does more. So you can take this into an application where you have a basic system, a 10, 12, 13 SEER, 14 SEER system that didn't have variable speed. Put this into the system and manipulate the conditions to whatever you want them to be. So I really like that. If the device fails, it's supposed to go and bypass and just blow at the maximum speed all the time, just like it would if you didn't have it on there. So, and if for some reason the device failed, you could still take the device out of the circuit and run your machine with the blower the way it was before. So there's a little contingency. Not like if you had a variable speed motor and it just tanked, you'd have to buy another one or rewire a PSC motor into it. This one you have some options. And if your motor dies, your PSC motor, well, they're less expensive to replace too. So to me, it's kind of it's a cool deal. Even if you'd have the humidistat or dehumidistat or whatever, you can use that as well. I didn't have that on this one, but maybe I'll do that in the future. So really cool. Let me know what you guys think about this product. I really like it. I bought a couple of them so I wanted to sell one first, and I did, so I went ahead and bought 2 of them. And I have one on the truck now, and I really have enjoyed how it's worked here. It lowers your humidity rapidly as long as the system's running, which is important. And the carrier system, I mean, it's not in perfect shape. You can see the suction pressure is a little bit lower than you probably would expect even at that air speed. There's some issues there. I think the TXVs, you know, one of the things where TXV doesn't let it quite as much refrigerant through it as it should, whether that be from wear and tear, debris on the TXV, whatever. The system's 16 years old. But it's doing pretty good, and it's really dehumidifying the air. And so I can assume that on a brand new system, it would probably do an even better job of doing those things. So if you have any questions about it, let me know. And I will see you guys on the next one.